Imagine a reinforced, locked, silent laboratory door. Behind it is not a secret formula, nor a lost relic. There is a machine.
It's not just a machine, it's a $400 million marvel of lasers and precision, churning out chips so advanced they're redefining power, speed, and the entire chip world.
Click the like button and activate the bell. And of course, I want to know your opinion.
The world of technology thrives on marvels that often remain hidden from public eyes, yet their impact is woven into the fabric of our daily lives. Every smartphone in our pockets, every laptop on our desks, every AI assistant that answers our questions, and every cloud server running the internet relies on microchips, tiny slices of silicon that represent humanity's most intricate handiwork. Behind these chips stands a colossal titan of engineering, a machine so advanced and so staggeringly expensive that it redefines the limits of possibility. This $400 million High NA extreme ultraviolet lithography machine from ASML is rewriting the rules of the chip world.
EUV. This technology uses light so short that it is absorbed by almost everything, even by the air itself.
At first glance, calling a machine worth $400 million a game changer sounds like an understatement. Its sheer price tag makes it one of the most expensive machines ever created, rivaling even Boeing aircraft, oil rigs, and space launch systems. Yet it is not its cost that makes it extraordinary, it is what it does. This beast of innovation is capable of etching features onto silicon wafers at scales so minute they are measured in nanometers, billions of a meter. To put this in perspective, a human hair is about 80,000 nanometers wide, yet this machine is engraving features as small as 8 nanometers, with even smaller dimensions on the horizon. Each etched pattern represents a transistor, and transistors are the fundamental switches that power every digital device. By cramming more transistors into the same chip area, computing power accelerates while energy efficiency improves, allowing us to leap into faster, smarter, more intelligent, and more connected futures, shaping industries, redefining innovation, and rewriting the possibilities of human technology.
Believed in extreme ultraviolet light. 3 years later, ASML was officially born. At first, no one took it seriously, not even the investors themselves. But the engineers persisted and failed repeatedly.
Also, the scale of the machine itself borders on science fiction. It is larger than a double-decker bus and weighs as much as 2 Airbus A320 airplanes combined. You cannot simply load one into a truck or ship it whole across the ocean. Instead, it must be dismantled into thousands of components and transported in parts, requiring 7 Boeing 747 cargo planes or a convoy of 25 trucks. The logistics alone cost millions, a testament to the machine's staggering size and complexity. When it arrives at its destination, it doesn't just get plugged in. Hundreds of highly trained engineers spend months meticulously reassembling and calibrating it inside cleanroom facilities, ensuring every lens, mirror, and alignment is tuned down to atomic precision. Watching its installation feels less like unpacking a machine and more like orchestrating a space mission, with every movement rehearsed, every step monitored, and every adjustment measured against the laws of physics themselves. It is a ballet of science and engineering, where failure is not an option and perfection is the only acceptable outcome.
Bet on something that no one believed in, extreme ultraviolet light.
But what truly elevates this High NA EUV machine into the realm of engineering legend is its core principle, extreme ultraviolet lithography. Traditional chip making involves shining light through a stencil-like mask to project patterns onto silicon wafers coated with light-sensitive material. The smaller the wavelength of light, the finer the detail etched. For decades, chip makers used deep ultraviolet DUV lithography, but as the demand for smaller transistors exploded, DUV hit its physical limits. Enter EUV, a light with an astonishingly tiny wavelength of 13.5 nanometers, generated using lasers so powerful they create plasma hotter than the surface of the sun. Mirrors coated with exotic multi-layer materials then reflect and focus this EUV light onto silicon wafers. Now, High NA takes this a step further by widening the lens aperture to capture more EUV light, which allows patterns to be etched with even greater accuracy. The outcome? Nearly double the density of transistors, enabling chips that are faster, more efficient, and packed with capabilities unimaginable even 5 years ago.
More production speed, fewer defects per layer, smaller, more efficient and cheaper chips.
This innovation could not have arrived at a more critical time. For decades, Moore's law, the prediction that the number of transistors on a chip doubles roughly every 2 years, has guided the semiconductor industry. Yet in recent years, skeptics declared Moore's law dead as the laws of physics made it increasingly difficult to shrink transistors further. The High NA EUV machine resuscitates this law, offering a technological lifeline that allows the industry to keep scaling. By enabling manufacturers to produce chips with transistor features down to 8 nanometers and beyond, it opens the floodgates to breakthroughs in artificial intelligence, quantum computing, autonomous vehicles, high-performance gaming, 6G networks, and energy-efficient data centers. Without this machine, our digital world would face stagnation. With it, the possibilities feel endless, transforming what once felt like technological limits into stepping stones toward a faster, smarter, and more interconnected future where science fiction steadily becomes everyday reality.
BO in 747 and dozens of trucks to assemble a single unit.
What's equally remarkable is how rare and exclusive this machine is. ASML, the Dutch company behind it, is the only manufacturer in the world capable of producing EUV lithography systems. No rival company, not in the United States, not in Japan, not in China, has managed to replicate the sheer complexity of this technology. ASML's ecosystem stretches across continents: mirrors from Germany, laser components from the United States, lenses from Europe, and assembly in the Netherlands. Each unit embodies a global symphony of engineering excellence, requiring thousands of suppliers and years of collaboration to bring a single system to life.
TSMC is already operating on American soil and ASML itself.
And because it is so unique, owning one of these machines has become a badge of honor among the world's top chip makers. Intel, TSMC in Taiwan, and Samsung in South Korea are the only companies to have received early shipments. Intel installed the very first commercial High NA machine at its Oregon facility in 2024, proudly declaring it the dawn of a new chip-making era. Reports from its early use are dazzling. The machine has proven twice as reliable as its predecessors, producing 30,000 wafers with improved yield and speed. Samsung, meanwhile, claims a 60% reduction in cycle time thanks to this powerhouse, meaning chips are produced far faster and at lower cost, reshaping competitive dynamics across the semiconductor landscape.
We made a full video showing the impact that the data centers are about to have on global energy consumption.
The implications ripple far beyond the factories. Every consumer gadget, from the latest iPhone to Nvidia's AI-dominating GPUs, stands to benefit. When your gaming console renders lifelike worlds at lightning speed, or when ChatGPT answers your question instantly, the invisible hand guiding that miracle is rooted in the work of these machines. Electric vehicles gain longer range and smarter navigation thanks to chips made more powerful and efficient by High NA technology. Data centers, the backbone of the cloud, consume less energy while crunching more data, helping cut carbon footprints in a time of urgent climate concern. Even national security hinges on this machine, as advanced chips are the core of everything from satellites to missile defense. From medical imaging breakthroughs to quantum computing research, its reach extends into realms once thought impossible. It fuels entire industries, reshapes economies, and decides which nations lead the future. It's not an exaggeration to say this $400 million giant is a cornerstone of global power. Of course, its exclusivity also makes it a geopolitical chess piece. Countries know that controlling access to ASML's machines means holding sway over the future of technology. The United States has pushed hard to ensure allies like Taiwan, South Korea, and Japan have access, while limiting China's reach to maintain strategic advantage. This tug of war underscores how deeply intertwined semiconductors are with global politics. Chips are not just components, they are currency, weapons, and lifelines. Europe, meanwhile, walks a fine line, balancing its economic interests with security obligations, while emerging powers scramble for partnerships, investments, and talent pipelines. The High NA machine sits at the center of it all, an irreplaceable asset that decides who leads, who lags, and who gets left behind in the digital age.
ASML has already understood this, which is why it is expanding its presence outside Europe.
The vision doesn't stop here. ASML is already working on the next evolution, known as Hyper NA, projected to launch between 2032 and 2035. If High NA feels like peering into the future, Hyper NA is the blueprint for a digital universe we can barely imagine today. To prepare, ASML has expanded its global training efforts, opening its first US training center in Arizona, where over 1,100 technicians per year will be trained to install, maintain, and innovate around these machines. This is not just about producing more chips, it's about creating an ecosystem of knowledge that sustains the semiconductor revolution for decades to come. Hyper NA will push boundaries even further, etching features so small they border on the quantum realm, enabling AI, biotechnology, and space exploration to reach entirely new frontiers. The race to master this machine will decide who controls tomorrow's computing power.
With ASML's original EUV machines in use now.
2,000 electrical connections, over 2 kilometers.
Perhaps the most astonishing part of this story is the sheer artistry involved in making something so complex function flawlessly. Each High NA machine requires components aligned with accuracy down to a fraction of a nanometer, smaller than the diameter of an atom. The mirrors alone are the flattest objects ever created by humanity, so smooth that if scaled to the size of the United States, no bump would be higher than a few centimeters. The laser system that generates EUV light is one of the most powerful ever deployed in a commercial machine, firing 50,000 laser pulses per second to strike molten tin droplets and produce plasma hotter than the sun. It is equal parts physics experiment, precision optics masterpiece, and industrial juggernauts.
Today, that number's grown to 44,000, and 8,500 of them are in the US, like Eric Ma, who's been with ASML in San Jose, California for 18 plus years.
For those eager to see it in motion, CNBC has captured a rare behind-the-scenes look at this colossal $400 million High NA system, showing its breathtaking size and engineering magic. Other deep-dive explorations explain how it accelerates chipmaking to record speeds, and short clips showcase its scale and vivid detail. Together, these videos peel back the curtain on a technology so advanced that it feels almost alive. It's like watching science fiction become reality, where lasers, mirrors, and precision engineering dance in perfect harmony to etch the future of computing. Every glimpse underscores its staggering significance. This isn't just a machine, it's the beating heart of tomorrow's digital revolution. The next time you hold your phone, stream a movie, or even ask AI a question, remember that all of it, every pixel, every word, every instant connection traces back to a single machine that costs $400 million and weighs as much as 2 airplanes. It is the unseen giant silently running the modern world, a machine so powerful that whoever controls it controls the future. What do you think about this cutting-edge technology, worth millions of dollars? Let's know your thoughts in the comments. Don't forget to like, share, and subscribe for more updates. Bye for now.